Alright, so hypothesis test. Step 1. Write hypotheses. And as I said before, your hypotheses in a chi-square test are always going to have the same format. Your null hypothesis is that there is no relationship between the two variables that you're looking at. In this case, those variables are gender and responses to the willingness to kill question. So I'm going to write that as there is no relationship between gender and willingness to kill. Your alternative hypothesis is, as usual, going to be the opposite of that. And so our hypothesis there is that there is some relationship between gender and willingness to kill. So in other words, in the first one, we're saying that gender has nothing to do with how people respond to that question. And in this one, we're going to say that if we reject our null hypothesis, we'll have evidence that men and women respond to the question in different ways. Step 2, test statistic. So as I said before, you guys are off the hook for calculating this test statistic. But I do want you to know what it means. So again, our test statistic is going to be called chi-square. And chi-square is, again, a measure of how different your observed frequencies are from your expected frequencies. And the more different these numbers are from these numbers, the bigger your chi-square statistic will be. And like all other test statistics, your chi-square statistic tells you where your sample data would fall on a sampling distribution if the null hypothesis were true. So if the null hypothesis were true and there was no relationship between gender and willingness to kill, you would have a chi-square distribution that looks something like this. So this is a sampling distribution. These are different possible sample chi-squares, and this is the probability of getting each one. This one, like other sampling distributions like this, has different shapes for different situations. In this case, it's based on the number of cells you have in your table. But since you're not calculating chi-square, I'm also not going to have you go through that. But this is generally the shape they usually take, which is a right-skewed distribution. So we're going to take your sample chi-square statistic, plot it on this sampling distribution, and use that to determine a p-value. In this case, like with the F distribution, your p-value is going to refer to the probability of obtaining a chi-square statistic as large as or larger than the one that you did in your sample. So if your p-value is, below the threshold set by the alpha level, then you would reject your null hypothesis. So basically, if it's very, very unlikely you would have gotten a sample chi-square statistic as large as you did, we'll take that as evidence that there is likely to be some relationship between your two variables in the population. So again, same logic as all the other hypothesis tests we've been doing. In this case, the test statistic is just chi-square rather than T or F. I also want to just take this moment to point out, since I want to make sure it's been clear throughout these lectures, the alpha level that's set by the researcher is a way of deciding how strict you want the test to be. So if you have an alpha level of 0.5, you're often going to be able to reject the null hypothesis because 5% of the time, just by chance, you'll have a sample statistic that's, this far out. If your alpha level is 0.001, you have to have a really, really, really unlikely sample statistic in order to reject the null hypothesis. Because there you're looking at only the 0.1% of least likely sample statistics. So that's the reason that we have different alpha levels. It's so that the researcher can decide how strict the test they want to be. So they want it to be relatively easy to reject the null hypothesis, but possible to have a mistake. Or do you want it to be really, really hard to reject the null hypothesis, meaning that sometimes you'll fail to reject it when you should. And I'm actually going to come back to these ideas a little bit next week, but for now, I just wanted to mention that since I've been giving you different alpha levels in the different problem sets, but I'm not sure it was clear why I was doing that. But again, those are just in order to, have tests that are more strict in terms of whether you're likely to accidentally reject the null hypothesis or fail to reject it. Okay, slight tangent there, we're coming back to the test. Step 3, decide whether to reject the null hypothesis. So here our chi-square statistic is going to produce a p-value, again because it's going to tell us where that sample statistic falls on this sampling distribution. So however far it is, we use the area under the curve in a more positive direction to find the p-value. This is again something that will be done by a computer and that I'll just report to you for you to interpret in the test. So in this particular case, our chi-square value is 1.07 and our p-value is 0.301. So in this case, we'll say that our alpha level is equal to 0.05, so not a very strict test. And we'll use that alpha level to decide whether to reject the null hypothesis. As usual, we're just going to compare whether p or alpha is larger. So in this case, our p-value, 0.301, is considerably larger than our alpha level, so we would fail to reject the null hypothesis. In other words, we do not have enough evidence based on our crosstab here to say that men and women answered this question any differently. So the differences that we see in the crosstab here, so 6 getting 6 rather than 7.6, getting 10 rather than 8.4, and so on. These are differences that would occur by chance approximately 30.1% of the time. So that's assuming that men and women answered this question exactly the same. So these differences that we see here in the sample don't give us enough evidence to say that in the population of criminal justice students as a whole, men and women are answering this question any differently.